Hi. Last week, we learned how to construct a truth table for a particular sentence. This week, we will work on the problem of constructing truth table for arguments. If you know how to construct truth table for a particular sentence, there shouldn't be any problem for doing the same thing for the whole argument, because an argument is nothing but a set of sentences. So let's look at an example. Here is an argument. There are two premises, and the conclusion is not P. It's a very simple argument. What should we do in order to construct a truth table for an argument like this? Just like the constructing truth table for a sentence, you write down the component sentences first. So if you look at this argument, there are two simple sentences, P and Q. So you write down PQ. And then you write down premises one after another. So you put down premises, premise 1 and premise 2. And finally, you write down the conclusion. When there are two component sentences, PQ, there are four different possibilities of combining truth values, TF. You remember? The first one was T. The second one, TF. Third one, FT. Last one, FF. So there are four possibilities. And for each of these possibility, calculate the truth table for each of these sentences. It's straightforward. Okay? So when P is true and Q is true, P then Q is true. Go back to the truth tables for the conditionals. When if you remember, it's TF, TT. Okay. Negation Q is the reverse of Q. Okay, so Q is TF, TF. So negation Q should be FT, FT. Okay, FT, FT. Conclusion is not P, so it should be the opposite of P. P is TT, FF, so not P should be FF, TT. Okay, so this much you shouldn't have any problem, because it's really the continuation of what we did last week, constructing truth table for each sentence. So we have done 3 sentences. Now, I mean, this is all there is to constructing truth table for any given argument. Okay, for some arguments it can be longer than others, but in essence, this is constructing truth table for an argument. Okay? Now, why do we construct truth table for arguments? The reason is we want to know whether the given argument is valid or not. As a logician, you are interested in the question about whether the conclusion follows from the premises. And truth table can give us very useful test of determining the validity of any given argument. Well, how do we do that? Well, for any given argument, the truth table test can determine whether that argument is valid or not. Well, how do we determine that? Well, you ask the question, is there any row in which all premises are true and the conclusion false? If there is at least one row in which that is true, then the argument is invalid. If not, the argument is valid. And that's how we use truth table to determine a given argument is valid or not. Let's go back to the previous example and ask yourself, there are 4 rows here. 1, 2, 3, 4. Okay? Is there any row? Okay, there are 4 rows in which all the premises are true. There are 2 of them, and the conclusion false. Well, we have to examine one by one. Okay? So, is there any row in which all the premises are true? Well, TF, FT, TF, yeah. The last one is where all the premises, in this case 2 of them, are true. Okay. Now, is the conclusion false? TTF. No. Conclusion is true. So that means there is no row. There is no row in which all the premises are true and the conclusion false. There is no such row. Okay? The only one that comes close to it was the last one, but even in this case, all the premises are true, but the conclusion is true. So there is no row in which all the premises are true and the conclusion is false. Okay? Now, what should we say then? It says, if there is no such row, then you conclude that the argument is valid. Okay? That's how we determine the validity of an argument by using truth table method. Okay. Now, in general, the number of rows that you need to complete for an argument with n component sentences is 2 to the power of n. So when you have 2 component simple sentences in an argument, 2 to the power of 2 equals 4. You need only 4 rows. That's what we did for the previous example. But when the number of component sentences increase, the number of rows that you have to construct for truth table increases exponentially. So when you have 3 component sentences, let's say P, Q, S, then the number of rows that you have to complete are 8. When the number of component sentences is 4, you have to construct 16 rows. Okay. So it depending on the argument that you have, the truth table method may take a long time. Okay. In principle, we can use truth table for any sentence to determine whether it is valid or not. But for an argument with many component sentences, the truth table method can be cumbersome and inefficient. It takes a long time to use the method. So in the textbook, the author introduces what's called the shortened truth table method. This method is really, in principle, it works the same way, but it really saves the time. Okay? So it's worthwhile to learn this technique. The shortened truth table test proceed in the following way. you try to make all premises true and the conclusion false by assigning truth values to component sentences. Okay? You try to make all the premises true and conclusion false. You try to do that, and if you succeed, then you have just shown that the argument is invalid. Okay? Now, if you have tried, but you couldn't make all the premises true and conclusion false, that means you fail, then that means the argument is valid. Okay? Let's work on an example, okay, to illustrate the idea. Okay, here is an example from the textbook. First, for the shortened truth table method, you write down the premises, okay, horizontally, not Q. The first premise, I'm just copying an argument from the textbook. The second premise is P, then Q or R. The third premise is R. The conclusion is P. It's useful to write down the slash in order to distinguish premises and the conclusion. For example, we can use this slash to distinguish different premises, and we can use double slash to differentiate the premise part and the conclusion. But anyway, so we try to, okay, let's try to make all the premises true and the conclusion false. Okay? You can start to work from the premises, or you can start work from the conclusion. Either way, it's okay. Okay? Whenever works. In this case, I will start from the premise. Okay? What I'm trying to do is I'm trying to make all the premises true and the conclusion false. So in order to make the conclusion false, P has to be false. Okay? Once P is determined of its truth value, you have to repeat that. So P is what? P is false. In order to make the third premise true, R has to be true. Once R is determined of its truth value, you repeat that. So R is true. In order to make this first premise, not Q, true, Q has to be false. Okay? Because I'm going to make not Q true, so Q has to be false. So Q is determined of its truth value as well. So you write it down. So far, okay, I have made first premise true, third premise true, conclusion false. Can I make the second premise true as well? Well, let's see. Second premise is basically a conditional statement. And you can tell from the truth table for the conditional connective, when the left-hand side is false, the whole conditional is true. So we have just made all the premises true and the conclusion false. Or to put it another way, there is at least one assignment of truth values for component sentences such that all the premises are true and the conclusion false. So that means this argument is invalid. Okay? The fact that all the premises can be true and the conclusion false means that the argument is not valid. Because validity of an argument means that if the premises are true, conclusion has to be true. So the fact that all the premises are true and the conclusion false means that the argument is not valid. So you can conclude that here. Actually, it would be nice if you write down the truth values P, Q, R. Okay, you say when P is false, Q is false, R is true. Okay, all the premises are true and the conclusion false. And you write down this argument is invalid. Okay, this argument is invalid. Something like this cannot happen in a valid argument. In a valid argument, you will never be able to find assignment of truth values that would make all the premises true and conclusion false. That will never happen in a valid argument. Okay, let's look at one more example. Okay. Here is an argument. There are two premises. And here is conclusion. Is this valid or not? Is this valid argument? The conclusion follows from the premises. We can use shortened truth table method to answer that question. Okay? Well, let's try. Our goal is we want to make all the premises true and conclusion false. Okay? I want to work on the conclusion first, okay? Because I see that Q or S is false only when both of them are. Okay? Let's see. Okay. So Q or S is false when Q is F, S is F. Disjunction statement or statement is false only when both of them are false. Okay? Remember? So we know that Q and S has to be F. We can repeat that here. Q, I know Q has to be F. S has to be F. Now, let's go to the first premise. I try to make the first premise true, and the first premise happens to be a conjunction statement, and statement. So, and statement is true only when both of them are true. So, this has to be true, that has to be true. Now, if I'm going to make P then Q true, given that Q is F, there is only one way I can do that. That is, P has to be false. If P is true, I cannot make P then Q true, given that Q is false. Because if P is true, then P then Q would be false. Okay? So I'm trying my best to make all the premise true and conclusion false. Okay? Same thing here. R then S can be true given that S is F only when R is F. Okay? That's the only way. So far I've made first premise true and conclusion false. And I've learned that P has to be F, R has to be F. Now, P has to be F, R has to be F. Now, look at here. If P is F and R is F, P or R has to be F. So that means I cannot make the second premise true. Okay? I cannot make the second premise true. So what this means is that I have failed. I have failed to make all the premises true and conclusion false. I've just learned that there is no way I can make all the premise true and conclusion false. Now in that case, I conclude this argument is valid. Okay? This argument is valid. So using the shortened truth table method to determine the validity of any given argument, okay, is the main thing, main work for this week. Okay, thank you.